Lesson 7 was all about solving radical equations again, but this time we had binomials on the other side, so we had to end up squaring binomials, and we had to watch out a little bit more for extraneous solutions than we did in the previous lesson. So we have to keep our eye out for extraneous solutions. So solve the following radical equations. Be sure to justify your solution set, aka check that there's no extraneous solutions. So our process is still the same. Isolate the radical. So I want to get that square root by itself there, so I'm going to have to add x to the other side. So I have the square root of 2x minus 7 equals x minus 3. Now that I have isolated the radical, I'm going to square both sides. And here's the thing. You have to square x minus 3 correctly. You are in Algebra 2, you're no longer in Algebra 1. You cannot make the 9th grade mistake of squaring x minus 3. Make a little table if you have to help you do it. X minus 3, x minus 3. X squared minus 3x, positive 9. So that equals x squared minus 6x plus 9. You cannot just write x squared plus 9 like a 9th grader would the first time they were squaring a binomial. We have to get past that and not make that conceptual error anymore. Subtract 2x from both sides, add 7. Why am I setting it equal to 0? I'm setting it equal to 0 because I now have this quadratic equation here that I have to solve. And the way we solve quadratic equations are we set them equal to 0, see if we can factor it, and then apply the zero product property. So, what two numbers multiply to 16 that add to negative 8? What two numbers multiply to 16 that add to negative 8? What two numbers multiply to 16 that add to negative 8? That sounds like negative 4 and negative 4. So I get x equals 4 and x equals 4. So really there's only one possible solution here of x equals 4. But I can't accept it that that's the solution until I go back and check. So we have to plug in x equals 4, because I had that repeated factor there. So the square root of 2 times 4 minus 7. So that's the square root of 8 minus 7. Square root of 1 is 1. So I have 1 minus 4. 1 minus 4 equals negative 3. It does check out. So x equals 4 is a solution to that equation there. This next one, 2x plus the square root of 4x minus 1 equals 2. Well, I'm going to subtract that 2x from both sides to isolate the radical, because that's my first step whenever I solve a radical equation, is to isolate the radical. Well, now that it's isolated, I can square both sides. And I'm left with 4x minus 1 equals, make a table if you have to. I'm squaring a binomial, 2 minus 2x, 2 minus 2x. So what goes in this table? 4 minus 4x minus 4x, positive 4x squared. So if I was to write this binomial squared in standard form, it would be 4x squared minus 8x plus 4. But it's a quadratic equation now, so I'm going to set it equal to 0. And I end up with 0 equals 4x squared minus 12x plus 5. And I now have to factor this trinomial to solve this quadratic equation. So I'm going to ask myself two questions. I'm going to say, self, what multiplies to 20 that adds to negative 12? What multiplies to 20 that adds to negative 12? Well, that's going to be negative 8. Nope, just kidding. Negative 4. Negative 2 and negative 10. So 4x squared minus 2x minus 10x plus 5. I split up that middle term there into negative 2 and negative 10. We can group now. I'm going to take out a 2x, and I'm left with 2x minus 1. I'm going to take out a negative 5, so I'm left with 2x minus 1. So my factors, I'm left with 0 equals 2x minus 1 times 2x minus 5. Well, that tells me that x equals, after I apply the zero product property, if this thing is 0, add 1 divide by 2, or x equals add 5 divide by 2. X equals 1/2, or x equals 5/2. I can't just go and box those in yet, because I need to go check, Are they actually solutions to this equation up here? So let's see, 2x, so 2 times a half, plus the square root of 4 times a half, minus 1, does that equal 2? Well, 2 times a half is 1, plus the square root of 4 times a half is 2 minus 1 is 1. 1 plus the square root of 1 is 1 plus 1 equals 2. That does check out. X equals 1/2 is a solution. Now let's check 5/2. Let's go back and plug that in to the original equation. 2x, so 2 times 5/2, plus the square root of 4 times 5/2 minus 1. Does that equal 2? Well, 5 plus, well, that's 20 over 2 is 10. Radical 9. Does 5 plus radical 9 equal 2? Does 5 plus 3 equal 2? It does not, so we reject x equals 5/2. That is an extraneous solution. It solves the quadratic equation we got, but it doesn't solve the original. So our only solution here is x equals 1/2. Make sure you're justifying your solution set and showing that check there of seeing that 1/2 is a solution, 5/2 is extraneous. The square root of x plus 4 equals 3 plus the square root of x. So this is one of those weird ones where we can't really isolate the square root because there's two different ones. So our strategy for this is to isolate one of them and square it. Well, this square root is already isolated, so let's square both sides. That way at least one of the square roots is gone. So we're left with x plus 4 equals, make a table to square that binomial over there. 3 plus radical x, 3 plus radical x. 9, 3 square roots of x, 3 square roots of x. Well, the square root of x times the square root of x is the square root of x squared. When you multiply two square roots together, you're left with the radicand, what's inside the radical, so you get x. So I get x plus 6 radical x plus 9. I need to isolate this square root now, so let's square root x, subtract x, subtract 9. So I'm left with negative 5 equals 6 radical x. If I divide by 6, I get negative 5 over 6 equals the square root of x. But then when I square both sides here, I get 25 over 36 equals x. Now I need to see if that's a solution. I need to check, is 25 over 36 a solution to that original equation up there, so we need to plug it in. We need to plug it in here. So I get the square root of 25 over 36 plus 4 equals 3 plus the square root of 25 over 36. Well, the right-hand side is easy to deal with. That's 3 plus, well, the square root of 25 is 5, square root of 36 is 6. If I was to write that as an improper fraction, that would give me 18 plus 5 is 23 over 6. Use your calculator there to help you out. The right-hand side is 23 over 6. On the left-hand side, if I was to write that as an improper fraction there, if I was to do 4 times 36 plus 25, I get 169 over 36. I'm square rooting that, which those happen to both be perfect squares, so I get 13 over 6. Does 13 over 6 equal 23 over 6? No, it doesn't. So we reject x equals 25 over 36 and call it an extraneous solution, so there are no solutions to this equation. There are no solutions here. The next one kind of combines two ideas together. I have radicals, but those radicals are in the denominator, and I have fractions, so it's kind of one of those rational equations where we got a common denominator. So it appears that everyone needs to have the square root of x plus 11 in the denominator. Well, this term is missing it, so I'm going to multiply it by x plus radical 11 over x plus radical 11. So that way I have a common denominator, equals 1 over radical x plus 11. Now that I have a common denominator, I look up at the top and I have x minus the square root of x plus 11 equals 1. Well, this is a square root equation, so I should isolate that square root. I'm left with negative radical x plus 11 equals 1 minus x. I'm going to divide by negative 1 to change everyone's sign there. So I'm going to get negative 1 plus x. I'm going to square both sides and get x plus 11 equals, well, if I square this out here, that's really x minus 1. I'm going to rewrite that as x minus 1. You can make a table if you need to, but you get x squared minus 2x plus 1. So we started with a rational, made it into a radical. Now I've got a quadratic equation to solve. Subtract x, subtract 11 to set it equal to 0, and get x squared minus 3x minus 10. And now I have to factor that trinomial by saying, what multiplies, by asking myself, what multiplies to negative 10 that adds to negative 3? I don't need to do the whole AC method here, and I get x minus 5x plus 2. So my solutions are x equals 5 or x equals negative 2. But I'm not done yet because I have to check. I have to go back and check that I don't have any extraneous solutions. So we have to check 5 and negative 2. So we have to check 5 over the square root of 5 plus 11 is 16, minus 1. Does that equal 1 over the square root of 16? Does 5 fourths minus 1 equal 1/4? Well, if you type 5 fourths minus 1 into your calculator, you will get 1/4 equals 1/4. So that checks out. So 5 is a solution. 5 is one of our solutions here. Now let's plug in negative 2 and see what we get. Now let's plug in negative 2 and see if that's a solution. So x negative 2 over, well, what's negative 2 plus 11? Radical 9 minus 1. Does that equal 1 over radical 9? Well, radical 9 is 3, so negative 2/3 minus 1. Does that equal 1/3? Well, negative 2/3 minus 1 is negative 5/3, which is not 1/3. So we do have an extraneous solution. We do have an extraneous solution here of x equals negative 2. So our final solution is just x equals 5.